Hello, Hornets, and welcome. Today, I'm going to be taking a look at the worksheet that I gave you on Friday. This is covering limits, finding velocities that are at rest given a position function, and finding equations of tangent lines, whether it's by hand or with a calculator, as well as finding derivatives using the product rule and the chain rule, and then finally, finding one-sided limits. This is a general review in preparation for our quiz, which is going to be next week. So the first problem that I had for you was the limit as x approaches 0, and we have x plus 1 to the 6th power minus 1 all over x. Now, when we plug in our value of x equals 0, we end up getting 0 over 0, which is telling me that I'm going to be using L'Hopital's rule. According to L'Hopital's rule, I can take the derivative of the top and the bottom separately and then reapply my limit whenever I get 0 over 0 or infinity over infinity. So we keep an eye out for that, and we will apply this rule. To do that, we take the 6 and move it in front. X plus 1 becomes to the 5th. The constant goes to 0. It is in terms of x and therefore a 1 in the denominator, and we are now allowed to reapply our limit. You'll notice we get 1 to the 5th, and that's just 1 times 6, and my answer is 6. Let's take a look at number 2. That was number 1. Number 2 is now asking me to find the limit as x approaches 0, and in the numerator I have the natural log of x plus 1. I am subtracting 0 in the numerator, and then I have an x in the denominator. Well, when I plugged in 0, I get the natural log of 1, which is 0, minus 0 is 0, and then a 0 in the denominator. So once again, L'Hopital's rule applies. We are taking the derivative of the natural log, which gives us 1 over x plus 1, times the derivative of the inside, which is simply 1, minus 0. 0 is just 0, and we have a 1. Now, when I plug in the 0, I end up with a limit of 1. Let's go ahead and take a look at number 3. Number 3 uses a trig. So I have the limit as x approaches 0, and I am looking at the sine of pi over 2 minus x this time. And I have the minus 48 divided by x. Now, please be careful. We now have a minus x here, so we just have to be careful because our derivative there is going to be a negative. So we might forget that or miss it. So let's go ahead and take our limit as x approaches 0. We're going to have the negative cosine pi over 2 minus x minus 0 divided by 1. And when we put in 0, we have the cosine of pi over 2, and there went my lights. The cosine of pi over 2 turns out to be 0, and therefore the negative becomes superfluous or not necessary, and we get a 0. Number 4 has the limit as x approaches 0 again, and this time we're looking at the numerator that has 3 times x plus 2, the quantity, and this is to the 4th power minus 48, and we're dividing by the x. Once again, when I put in 0, I get 48. Minus 48 is 0 over 0. So I take the limit as x approaches 0 for the derivative. This gives me 12 times x plus 2 to the 3rd power minus 0 over 1. And as I take the 0 and I plug it in, I'm going to have 2 to the 3rd power is 8. 8 times 12 is going to give me, I believe, 96. Let's just double check that real quickly. That's 80. 80 plus 16, and I get 96. Going to number 5. This is the last one, and please be aware this will be the last part of this video, and I'll continue in part 2. So we'll have the limit As x approaches 0, we are going to be working with the function x plus 3 to the third power we have minus 27, and we're dividing by x. As we saw before, we're getting 0 over 0 when we plug in the value. That's always the first step. And then once we recognize the 0 over 0, we use L'Hopital's rule. 3 times x plus 3 to the second power minus 0 divided by 1. And now I have 9 times 3 makes 27. This is the first part of that work for practice in preparation for our quiz next week. I will be in this activity. You will see that I have posted part B and C, and I should be able to get this done in 3 parts. Thank you very much. Please be well, take care, and be safe, and I hope this helps. Bye-bye. Be well all.